In 2011, NASA's Messenger probe made history by entering Mercury's orbit and capturing some astonishing images. Imagine this. On a planet so scorching that lead could melt, Messenger discovered billions of tons of ice. How could that even be possible? Despite Mercury often being closer to Earth than Mars, it's one of the least explored planets in our solar system. What other mysteries does this enigmatic world hold? In this video, we'll uncover where life might be hiding on Mercury, how it could threaten all life on Earth, and how this planet could potentially offer humanity an endless supply of energy. Plus, we'll reveal secrets about Mercury that could completely change our understanding of it. Mercury is perhaps the most challenging planet to explore, even though it has been observed for thousands of years. The Babylonians, more than 2,000 years ago, were fascinated by Mercury's peculiar movement in the sky, which sometimes seemed to go backward. They couldn't explain this strange behavior. But later, the ancient Greeks noticed that Mercury moved faster than the other planets, naming it after Hermes, the swift-footed messenger god. The Romans adopted this name, and that's how the planet got its name, Mercury. It wasn't until the 16th century that Galileo finally solved the mystery of Mercury's odd motion. It revolves around the sun much faster than Earth, making it appear to move backward at times. This is the same retrograde Mercury that astrologers often blame for all sorts of troubles. Galileo made this discovery thanks to the telescope, but studying Mercury has always been a difficult task. The planet is so close to the sun that even modern telescopes like Hubble and James Webb are hesitant to take a closer look for fear of damaging their sensitive equipment. So why not just send a spacecraft? It's not that simple. Getting close to the sun requires a probe to slow down significantly. In 1973, NASA's Mariner 10 had to take a complex route around Venus to finally reach Mercury's orbit in 1974. It circled Mercury 3 times and took the first ever photos of its surface, which looked a lot like our moon. This led scientists to speculate that Mercury and the moon might share a common ancestor, but chemical analysis showed they are entirely different. Mercury, it turns out, has some unique surprises. For example, a day on Mercury lasts 176 Earth days, twice as long as a Mercury year, which is only 88 Earth days. Wrap your mind around that. One day on Mercury is 2 years long. And what about those mysterious tails glowing from Mercury, almost like cosmic spotlights? They puzzled scientists for years. Could Mercury be a giant comet? It seemed absurd until the Mariner 10 mission. Before this, scientists thought a planet as small as Mercury couldn't have a magnetic field, but the probe detected a faint one that can cause magnetic storms. These storms attract hot solar wind plasma, which hits Mercury's surface and pushes atoms upward, creating those strange comet-like tails. But where did Mercury's magnetic field come from? It turns out that Mercury's core is unusually large, making up 70% of the planet's mass, whereas Earth's core is responsible for only 1/3 of our planet's mass. This oversized core is why Mercury hasn't cooled down from the inside, unlike Mars, which is almost entirely cooled. But this raises another question. How did Mercury end up with such a massive core? One theory suggests that billions of years ago, a colossal celestial collision might have played a role. Mercury, the smallest planet in our solar system, has always intrigued scientists with its peculiar characteristics. For a long time, it was believed that a collision stripped away much of its rocky outer layers, leaving behind a large core. However, recent research points to a different culprit, the Sun. In the early days of our solar system, the Sun was surrounded by clouds of gas and dust. Its powerful magnetic field attracted iron particles, so the planets forming closer to the Sun, like Mercury, ended up with a higher iron content. This explains Mercury's oversized core, but that's just the beginning of its mysteries. When scientists closely examined images of Mercury's surface, they discovered large rocky formations that resemble steps in a landscape, stretching for hundreds of kilometers. The longest formation is nearly 1,000 kilometers long. The prevailing theory is that as Mercury's core cooled, it shrank and caused the surface to wrinkle, similar to how grapes turn into raisins. But here's the twist. These formations are not evenly spread across the planet. Instead, they are clustered in 2 bands on opposite sides, with twice as many in the southern hemisphere as in the northern one. Some scientists believe this could be due to the expansion and compression of the mantle layer, but others argue that the mantle is too thin for this to be the case. This puzzle remains unsolved. To uncover more about Mercury, the Bepi-Colombo probe was launched and is set to reach the planet in 2024. The first images from the probe have already shown more wrinkles on Mercury's surface, suggesting that the planet is still shrinking. But there's more. Mercury is rich in volatile substances like water, sodium, and carbon dioxide. These materials should have evaporated long ago due to the sun's intense heat. So how did Mercury manage to hold on to them for over 4.5 billion years? One theory suggests that Mercury may have formed further from the sun and later migrated closer due to gravitational forces, possibly influenced by Saturn. But this raises another question. If Mercury formed farther away, how did it end up with such a large metal core? Adding to the mystery, scientists have found an unexpectedly large amount of water ice on Mercury, even though surface temperatures can soar above 400 degrees Celsius. Some of this ice lingers in shadowed craters and at the poles, but there's more water on Mercury than anticipated. It turns out that the sun itself might be responsible for creating some of this water. Mercury's surface contains hydroxy groups, linked oxygen and hydrogen atoms. When protons from the solar wind hit Mercury's surface, they can activate these hydroxy groups, causing them to form water molecules. While some of these molecules evaporate into space, others settle in shaded areas, accumulating as ice over time. In fact, scientists estimate that Mercury could accumulate nearly 10 trillion tons of new ice in just 3 million years. So does this make Mercury a more viable candidate for colonization than Mars? With its water ice and other intriguing features, Mercury might just surprise us yet again. Mercury receives 6 times more sunlight than Earth, offering immense potential for powering colonies for centuries. You might wonder why we haven't settled there yet. While scientists see Mercury as a possible future cosmic solar power station, the challenges are daunting. For instance, it took NASA's Messenger probe 7 years to reach Mercury, requiring multiple orbits around Earth, Venus, and Mercury to slow down enough. Imagine spending that much time on a colonization ship. And even if you make it there, landing on Mercury is no easy feat. The planet has almost no atmosphere to slow down a spacecraft, making it one of the trickiest places to land in the solar system. Once on the surface, you'll face extreme temperature swings, ranging from minus 180 degrees Celsius at night to 400 degrees Celsius during the day. With Mercury's day lasting 176 Earth days, timing your landing to avoid the worst of these extremes is crucial. However, Mercury's unique orbit can cause the sun to rise twice in a row, so you might still face unexpected temperature shifts. Mercury's low gravity, which is almost a vacuum, poses additional dangers. Without proper protection, your lungs could be torn apart, and your blood could start boiling within seconds. Spacesuits for Mercury must be highly specialized, not just to keep you alive, but also to withstand the planet's harsh conditions. Colonists might even need to become miners to survive, as Mercury's lava tubes, remnants of ancient volcanic activity, could provide shelter. Some of these tubes are deep enough to house entire cities, maintaining a steady temperature of around 21 degrees Celsius and offering a way to recreate Earth-like conditions. Another survival strategy would be to build mobile settlements that move continuously westward, staying in the zone between the scorching day and the icy night. The slow sunrise on Mercury means these mobile homes wouldn't need to move very fast, making this approach feasible. However, the most promising option might be to construct cities in craters at Mercury's poles. Some craters are up to 100 kilometers in diameter and could easily accommodate megacities like Beijing or Tokyo. The crater walls would shield inhabitants from the sun, and solar panels could be installed on the edges to harness energy. A giant dome could cover the crater, maintaining a comfortable microclimate, while a system of mirrors could ensure a steady water supply and even support plant growth. Yet, even if you manage to avoid Mercury's most significant threats, the planet's weak gravity will take its toll. With gravity 3 times weaker than Earth's, colonists could leap great distances and lift heavy objects easily. However, prolonged exposure to low gravity could lead to muscle and bone atrophy, as well as vision and cardiovascular issues. The next generation of Mercury colonists could be leaner, with weaker muscles, thinner bones, and possibly even darker eyes due to the intense sunlight. They might look like real aliens compared to us. But what if life already exists on Mercury? Despite its deadly environment, Mercury might be hiding life in its thin atmosphere, or exosphere. The density of molecules in this exosphere is so low that they rarely collide. But scientists have detected oxygen, water vapor, and even methane, possible signs of life. Could Mercury harbor some unknown form of life that we've yet to discover? The mysteries of this small but fascinating planet continue to challenge our understanding. Surviving on Mercury seems impossible with its scorching temperatures and lack of liquid water on the surface. However, there's a theory that deep within Mercury's lava tubes, there could be reservoirs of liquid water. According to Alexis Rodriguez from the Institute for Planetary Sciences in Arizona, if water compounds still exist in Mercury's exosphere, it's likely that liquid water could be hidden deep in these underground tunnels. If this is true, it raises the fascinating possibility that a unique ecosystem might be thriving in these dark, water-filled caverns. But what if life on Mercury is even more advanced than we imagine? Recently, the Bepi-Colombo probe detected something strange around the planet, a surge of electrons triggered by X-ray radiation, creating what could be described as an invisible radioactive aurora. This phenomenon typically requires a thick atmosphere to occur, where charged particles interact with atmospheric gases. Given Mercury's thin exosphere, such an event should be impossible. But what if these are signs of an underground civilization on Mercury, harnessing solar flares to power their technology? While we're speculating about life on Mercury, the planet itself could be a future threat to Earth. Mercury's orbit is highly elliptical, bringing it as close as 47 million kilometers from the Sun and as far as 70 million kilometers. Astronomer Jacques Lascar from the Paris Observatory used computer simulations to show that, over time, Jupiter's gravitational influence could stretch Mercury's orbit even further, potentially causing it to cross paths with Venus. This could lead to a catastrophic collision between Mercury and Venus, sending Mercury careening through the solar system. In the worst-case scenario, Mercury could collide with Earth. If that happens, it would be the most devastating event in Earth's history. For perspective, the asteroid that wiped out the dinosaurs was only about 10 kilometers across, while Mercury has a diameter of nearly 5,000 kilometers. A collision of this magnitude would mean the end of life on Earth as we know it. Even Mars, our potential backup planet, wouldn't be safe, as a rogue Mercury could head there next. Fortunately, Lascar's study suggests there's only a 1% chance of this happening, meaning we're 99% safe for the next few billion years. Unless, of course, the Bepi-Colombo probe uncovers something that changes our understanding of Mercury entirely. Interestingly, we might pose a greater threat to Mercury than it does to us. According to Soviet astrophysicist Nikolai Kardashev, humanity will need to harness the energy of the Sun to advance to a Type II civilization. This would involve constructing a Dyson sphere, a massive structure that captures all of the Sun's energy. Canadian futurist George Dvorsky proposed that Mercury could play a key role in this project. The idea is to dismantle Mercury entirely, using its rich iron core and other resources to build the Dyson sphere. But is this the best use of Mercury? Or would it be better to preserve the planet and perhaps even turn it into a tourist destination where people can witness the rare double sunrise? The future of Mercury is filled with possibilities, both as a potential threat and as a resource that could help humanity reach new heights. Whether we should exploit Mercury for its resources or preserve it for future generations is a question that may shape our journey into the cosmos.